Bismillahirrahmanirrahim. It's our sixth lecture of our course Calculus 2. In this lecture, we will study partial derivative of more than two variables. It is same as we did for the partial derivative of two variables. But of course, we are having the third one variable. So now we will see how we can solve that. Our function is f of x, y, z equal to x cube, y square z4 plus 2xy plus z. We have to find the fx, fy and fz. But for fz, we have values -1, 1, 2. We have to put these values and find out the final answer of fz. F of x is equal to partial by partial of x, and our function, which is x cube y square z4 plus 2xy plus z. When we take the derivative with respect to x, our other values y and z will be constant. So partial by partial of x cube will be 3x square. Other values will be as it is. If you have confusion that why we are taking them as it is, basically it is a step which I am not doing, that partial by partial of x and the values x cube plus x cube y square z4, which means that when we are taking the derivative of x cube, we will take the other constants outside the derivative. Y square z4 partial by partial of x cube y square z4 and 3x square. It will be 3x square y square z4. This is what we are taking here. So we have 3x square y square z4 plus, as I told you that 2 and y will be constant, it will be outside from the derivative. Partial of x by partial of x will be 1. So 2y plus z, partial of z by partial of x will be 0. The derivative of the constant is 0. So it is f of x is equal to 3x square y square z4 plus 2y. Now we will take the fy, which is partial by partial of y, and our function, our expression x cube y square z4 plus 2xy plus z. So for this we will take the x and the z constant. So fy is equal to the derivative of y, it will be 2y x cube z4 plus, as the x is constant, 2 is constant, it will be outside, and partial of y by partial of y will be 1, and derivative of constant is 0. So fy is equal to 2x cube y z4 plus 2x. This is our answer of the fy. Now we have to find out the fz, which says that partial by partial of z, our expression, that is x cube y square z4 plus 2xy plus z. In this, our x and y will be constant. So our answer is fz is equal to 4z cube. X cube and y square will be constant, plus here we don't have any z value, so it will be 0, and partial of z by partial of z is 1. So fz is equal to 4z cube x cube y square plus 1. As I told you that we have to find out the fz at -1, 1 and 2. So it means our x is -1, our y is 1 and our z is 2. Now we will put these values as, at the place of z we have to put the z value, at the place of y we will put this value, and the place of x we will put this value. We have to put in this expression. So f of z is equal to 4. Z cube means 2 cube x cube minus 1 cube, and at the place of y we will put the 1 square plus 1. It will be 4 into 8 minus 1, and 1 will be 1 as it is. So plus 1, 4 8s are 32, and from this we have the minus sign. Minus 32 plus 1, it will be minus 31. So our FZ is equal to minus 31. This is how we solve the partial derivative of more than two variables. Now we will solve the one more example, that our expression is, our function is function of rho into theta into phi. We are having the three variables equal to the rho square cos phi into sine theta. We have to find the function of rho in which our theta and phi will be constant. We have to find the f theta in which our rho and phi will be constant, and we have to find the f phi in which our theta and rho will be constant. So starting from the f of rho, we will solve our this expression. So 2 rho and the other values will be as it is, cos phi sin theta. To find the f theta, our theta value, we will solve the theta value and other will be constant. So rho square as it is, cos phi as it is. We have to solve the sin theta, and the derivative of sin theta is cos theta. As we are taking the f theta, so it means the partial of theta by partial of theta. We have to take the partial of angle with respect to theta. So it will be 1, so we are not writing it here. So now we have to find the partial f of phi, which means the other values will be constant. So rho square cos of phi is minus sin phi. Cos theta will be, sin theta will be as it is. So f of phi is equal to minus rho square sin phi sin theta. This is how we solve our partial derivative of more than two variables. I hope this topic is clear to you. If you have any kind of question, you may ask in the comment section.